Hello friends, welcome back. In this tutorial we will study about look ahead carry generator. Now suppose there are two binary numbers A and B. A equals to A4, A3, A2, A1, where A4, A3, A2, A1 are the bits of binary number A. And B equals to B4, B3, B2, B1, where B4, B3, B2 and B1 are the bits of binary number B. Now we have to add these two numbers by a binary parallel adder. These two binary numbers are 4-bit binary numbers, so we need a 4-bit binary parallel adder to add these two numbers. A 4-bit binary parallel adder will consist of 4 full adders, and they will be connected in cascade. Output carry of one full adder will be the input carry of the next full adder. All bits of the binary numbers A and B will be applied simultaneously. Here symbols C1, C2, C3, C4 and C5 represents carries, and S1, S2, S3, S4 are the sum bits. Now look at this full adder. This can't produce correct value of S4 and C5 unless it has correct value of C4 along with A4 and B4 as input. C4 is produced as output by this full adder. This full adder can't produce correct value of C4 unless it has correct value of C3 along with A3 and B3. Now C3 is the output of this full adder, and this full adder cannot produce correct value of C3 unless it has correct value of C2 along with A2 and B2, and C2 is the output of this full adder. So it means C4 has to wait for C3 and C3 has to wait for C2, which results in more time consumption to produce correct sum by binary parallel adder. Now to overcome this limitation, we will add some logic to the binary parallel adder so that C4 doesn't have to wait for C3 and C3 doesn't have to wait for C2. It means all carries C2, C3 and C4 are available at same time. So first of all, see the logic diagram of this full adder. Now suppose this is the ith full adder of some binary parallel adder, right? Now let's its input carry is Ci, and the input bits to be added are Ai and Bi. Ai and Bi are the bits, ith bits of binary numbers A and B, which are to be added by binary parallel adder whose ith full adder is this one. This is the full adder of ith stage. Now let Pi is the output of this exclusive OR gate and Gi is the output of this AND gate. So the function for Pi and Gi are written here. Pi equals to Ai XOR Bi and Gi equals to Ai and Bi. Now this full adder has two output variables Si and Ci plus 1. Si represents the sum bit and Ci plus 1 represents the output carry. Now here Si is equals to Pi XOR Ci, right? And Ci plus 1 equals to Pi and Ci plus Gi. And what the Pi and Gi are? Pi equals to Ai XOR Pi and Gi equals to Ai and Bi. So now by this expression we can get the value of C2, C3 and C4. Now when the value of I equals to 1, then this expression will become C2 equals to G1 plus P1 and C1. When I equals to 2, then this expression will become C3 equals to G2 plus P2 and C2. Now here C2 equals to G1 plus P1 C1. Now put the value of C2 in this expression. So it will become G2 plus P2 ANDed with G1 plus P1 and C1. So it will be equal to G2 plus P2 G1 plus P2 P1 C1. Similarly, we can find the value of C4. Here C4 will be equal to G3 plus P3 C3. Now put the value of C3, that is G2 plus P2 G1 plus P2 P1 C1 in this expression. So it will become G3 plus P3 G2 plus P3 P2 G1 plus P3 P2 P1 C1. Now we have got Boolean functions for C2, C3 and C4. Now C2, C3 and C4 are the Boolean functions which are formed of variables P1, P2, P3, G1, G2, G3 and C1. So we can design a combinational circuit called look ahead carry generator, whose input variables will be P3, G3, P2, G2, P1, G1 and C1, and output variables will be C2, C3 and C4. right? So this look ahead carry generator, this combinational circuit will generate value of output variables C2, C3 and C4 at the same time. C2, C3 and C4 are the carries. So these are the Boolean functions for C2, C3 and C4 in terms of P3, G3, G2, P2, G1, P1 and C1. So from these Boolean functions we can make a logic diagram for this combinational circuit called look ahead carry generator. This is the logic diagram for look ahead carry generator. These are its output variable and these are its input variable. This combinational circuit called look ahead carry generator generates all the carries C2, C3 and C4 at the same time. Now C4 doesn't have to wait for C3 and C3 doesn't have to wait for C2. Now we can add this logic of look ahead carry generator with 4-bit binary parallel adder. Now this is the 4-bit binary parallel adder along with look ahead carry generator. Now, as I have told earlier, how Pi and Gi are produced, right? Now these are the input variables of the combinational circuit look ahead carry generator, right? Pi is the output of exclusive OR gate whose inputs are the ith bits of binary numbers to be added, that is Ai and Pi. Gi is the output of an AND gate whose inputs are ith bits of binary numbers to be added, that is Ai and Pi here, right? So the input variables of look ahead carry generator are P4, G4, P3, G3, P2, G2, P1, G1 and C1. Now, output of these exclusive OR and AND gates provides the values of input variables of look ahead carry generator. Now this C1 is the input carry of first full adder of binary parallel adder. Now if this binary parallel adder is connected to another binary parallel adder in such a way that output carry of that binary parallel adder is connected to the input carry of first full adder of this binary parallel adder, then the value of C1 will be equal to the output carry of that binary parallel adder. If this binary parallel adder is not connected in such a way with any other binary parallel adder, then the value of C1 will be taken 0. Now, the output variables of this look ahead carry generator are C2, C3, C4 and C5. Here C2, C3, C4 and C5 represent the carries, right? C2 is the output carry of first full adder, C3 is the output carry of second full adder, C4 is the output carry of third full adder, and C5 is the output carry of fourth full adder of this binary parallel adder, right? Now, these all carries are produced, or we can say these all carries are available at same time because of look ahead carry generator. Now see here, the SI is the ith sum bit. Ith sum bit is equal to Pi XOR Ci. So S1 is the output of XOR gate whose inputs are P1 and C1, right? And S2 is the output of XOR gate whose inputs are P2 and C2. S3 is the output of XOR gate whose inputs are P3 and C3. And S4 is the output of XOR gate whose inputs are P4 and C4. So now here C4 doesn't have to wait for C3 and C3 doesn't have to wait for C2. Thank you very much.